I promised to tell about the boundary of observability in physics. If you search the internet, you will hardly find such a term. Consider it my know-how. Say, you're being overconfident. Perhaps I am. But the introduction of this concept and its explanation allow us to solve some problems of modern physics and to look at the world around us in a somewhat different way. Questions about the nature of light and its speed arose a long time ago and remain relevant to this day. Almost all generations of scientists, both physicists and philosophers, have argued about it. And the current, dominant concept of scientific views in many physical disciplines appeared as a consequence of the discussion of issues related to light, with its structure, speed and medium of propagation. Let me remind you that in the second half of the 19th century in the minds of scientists firmly planted the idea of the presence of the so-called light-bearing ether, a certain medium for the spread of light in the universe. The reason for the emergence of such an idea is obvious. After all, for example, for the spread of sound, you need some medium capable of transmitting sound waves. Therefore, the assumption of the ether arose. This theory was first formulated by René Descartes in the 17th century. I will not recount the vicissitudes of the fierce scientific battles around this issue, but I will note that among the supporters of the theory of ether were many prominent scientists. For example, Poincaré and Lorentz, whose role in the formation of the theory of relativity is undeniable, were strong supporters of the ether. And Maxwell himself, the author of the famous formulas that gave impetus to the emergence of the theory of relativity and modern physics, considered the ether as a medium not only for the propagation of light, but also electricity and magnetism. Not only physicists were engaged in the ether. Dmitry Mendeleev seriously considered the ether as a prototype of all the elements of his table, considering it the lightest chemical element. Naturally, scientists made a lot of attempts to experimentally find confirmation of the existence of ether and determine its characteristics. The most famous, which has become a kind of classic, is considered to be the Michelson-Morley experiment, repeated many times by different scientists, under different conditions of this experiment with the same result. Experimental confirmation of the existence of the ether was not obtained. It should be noted that nowadays there are attempts to repeat this experiment from time to time, taking into account new technological possibilities. But the result remains unchanged. Therefore, at the end of the 19th century there was a need for a theory that could explain the nature of light and its propagation in the absence of ether. It is worth noting that in addition to the medium of propagation for electromagnetic waves, the question of the speed of light itself was actively discussed. In itself it was known with high accuracy, but this speed was calculated as the average speed in the propagation of light in the forward and reverse direction. That's why it was called the two-way speed of light. And 100 years ago, and in our time, remains open question about the one-way speed of light. As it turns out, it's impossible to measure. The problem is related to the synchronization of clocks between the point of departure and the point of receipt of light. That in turn gave reason to assume the admissibility of different speeds of light in different directions. In one of his first papers on the theory of relativity, entitled Toward Electrodynamics of Moving Bodies, published in 1905, Albert Einstein speculated about the speed of light and proposed to consider it constant in all directions and for all reference frames. With this he formulated the second postulate of his special theory of relativity. This agreement allowed the construction of the entire mathematical apparatus of Einstein's theory, although all experimentally verifiable predictions do not depend on the agreement on the constancy of the speed of light. If you are familiar with the mathematical apparatus of relativity theory, you may exclaim, but the speed of light appears in all formulas. However, serious scientists instead of the speed of light speak of a fundamental constant numerically equal to the bilateral speed of light. Even the author of the theory of relativity in his work called it a universal constant equal to the speed of light in a vacuum. In minds and speeches of popularizers from science, the given nuance is erased and they tell about speed of light in formulas of the theory of relativity. Caution of serious scientists is understandable, as if one-sided speed of light cannot be measured, there is no direct proofs of equality of speed of light in different directions at measurement of two-sided speed. The absence of ether is not at all a sufficient condition for such equality. I will say more, if you change the numerical value of the fundamental constant, nothing will change in the conclusions offered by the theory of relativity. There will simply appear other values of familiar to us quantities, depending on this constant. For example, the frequency range of light waves. Another thing, if there will be strong evidence of different speeds of light at different directions. In this case, the area of applicability of Einstein's theory will narrow to the condition of equality of the speed of light in different directions. As it happened in due time with Newtonian physics, whose sphere of applicability narrowed down to velocities many times lower than the fundamental constant. Note that constants in mathematical expressions describing physical processes must necessarily have a certain physical meaning. Einstein chose the constancy of velocity for a reason, but to understand the reasons for this choice, let's go back to the end of the 19th century and remember Ernst Mach, the famous Austrian physicist and positivist philosopher. At this time, there was a crisis in physics due to the emergence of new experimental data, which turned out to be inexplicable within the framework of classical physics. We will not go into this topic, but Mach's philosophical views had a significant impact on the relativistic attitude to space, time and mass, which were previously considered absolute. And, perhaps most importantly, on the methodology of science that many scientists of the time, including Einstein and Poincaré, came to adhere to. Briefly, Mach argued that the world around us is a complex of our sensations. In his view, only what is observable exists. Based on this principle, Mach, for example, rejected the existence of atoms, considering them a convenient mental construct to explain a number of physical and chemical phenomena. Incidentally, it was he who introduced the concept of mental experiment into scientific usage. Some of Mach's conclusions today look extravagant, but in the essence of his approach to the methodology of science, he is right. We really know the world through the senses. For myself, I would add, seeing the world depends entirely on the characteristics of these senses. The most fast-acting organ of the human body is vision. By the term fast-acting I understand the speed of external signals, which a particular sense organ is able to perceive. It is possible to formulate in another way and under quickness to understand the maximum speed of data arrival, which can be perceived by a sense organ. I considered this nuance in the video about physics as an information system. The link to this video is given in the description. However, let's continue. The signals received by the senses have other characteristics besides speed. For vision, for example, these are color sensations. And for hearing, it's the frequencies of sound vibrations, known as tones. That's why the black and white world in a dog's eyes is strikingly different from the world through its master's eyes. And the sound picture of a cat is many times brighter than the picture available to humans. Thus, we can say with full confidence that the speed of light is a subjective essence and represents the boundary of observability of the surrounding world by man. Because of this, the speed of light is constant for human perception and does not depend on the direction of light propagation. Therefore, the second postulate of the theory of relativity can be considered fair, but at the same time useless in the physical sense. Physiological limitations of our observation ability exclude, for example, addition of two light velocities. Therefore, indeed, The speed of light from a flashlight fixed on the nose of a spaceship flying at the speed of light will remain for a human observer the same speed of light as from a stationary flashlight. These physiological limitations also explain the impossibility of measuring the one-way speed of light. It is equal to the attempt of the legendary Baron Munchausen to pull himself out of the swamp by his hair. The conclusion from the Lorentz transformations about impossibility of overcoming by a material body the speed of light is conditioned by impossibility of a human being to adequately observe the processes, whose speeds exceed the speed of light. The physical meaning of the fundamental constant in the formulas of the theory of relativity is not the disappearance of material bodies at the speed of light, but their disappearance from our field of vision. That is why the formulas of the theory of relativity have a sphere of applicability only within the boundaries of observability. The legitimate question is why we will not be able to observe bodies accelerated to supersonic speeds. The short answer can be formulated as follows: our observation of such bodies will be available, but the picture of these observations will be strongly distorted and difficult to analyze. About it I spoke in detail in the video devoted to observation of processes occurring with superluminal speed. The link to this video is given in the description. By the way, imagine the picture of the world if mankind had no vision. Without any doubt, scientists of such humanity would choose the speed of sound in water as the previously mentioned fundamental constant. Ask why in water and not in air. Such a question is obvious, for humans are not ichthyanders. This is true, but scientists of blind humanity would have discovered quite quickly the change in the speed of sound when water enters the ear. Probably each of you when bathing in the river or sea faced such a situation. Try to remember how the sounds you heard changed when you did so. And one more remark. Speed of sound in water such hypothetical blind mankind could get only as averaged in bilateral variant, as sighted mankind gets bilateral speed of light. If you think otherwise, suggest in the comments a mental experiment on how blind humanity could determine the unilateral speed of sound. Thanks for your attention, subscribe to the channel and see you soon.